everyone. A very good evening. Hope you all are doing great. I am Jhumpa Mukherjee, Brand and Media Manager at Minimac Systems. Today, we are here for an insightful session, and we are doing this for the first time in Series 2, having 4 experts together answering the questions and queries related to filtration and oil reclamation. The flow of today's webinar will be different from the past ones. We are having an open webinar today where you can post your questions and queries in the Q&A box and our experts will answer them live. So instead of 30 minutes of AMA session, which we used to have, today we are having 90 minutes of AMA session. Isn't it great? Please reply on the chat box and let us know how excited you are for the session today. Let's meet our experts. Let me introduce our first panelist, Mr. Anshuman Agrawal, founder and managing director of Minimac Systems. He has more than 15 years of experience in various technology solutions, and his vision and dedication have significantly influenced the reliability and maintenance industry globally. We have with us Mr. Greg Livingstone, Chief Innovation Officer in Flutech. He has vast knowledge and understanding on why oil fails and how to detect fluid degradation and developing technologies to extend their life. He has expertise in oil degradation, varnish, and turbo machinery. Welcome, sir. And the next panelist we have with us today, Mr. Rennie Stephens. He is a trainer and reliability engineer at CMS Engineering. He provides new insights into all aspects of tribology that determine the lifespan, performance, and reliability of machines and their parts, which helps improve machine performance and productivity. And Mr. Yogesh Kumar, technical head at Minimac Systems. He has over 11 years of experience in streamlining operation and maintenance and commissioning within the thermal plants. I would like to welcome all the experts and thanks for your presence.
Thank you so much, Jhumpa, for inviting us on this platform.
Wonderful to be here. Thank you.
I'm certainly honored to share the stage with the experts and the stalwarts of the industry. Thank you so much, Greg, Ben, and Mr. Yogesh for joining out here.
Great to be here. Thank you.
Okay.
Yeah, so make sure that your video and audio is always on. And let's start today's session with the questions we have received through our social media channels. Meanwhile, the audience can pose their questions in the Q&A box. To the experts, I would like to mention that it would be great if you can add your thoughts and experiences to the answers given by other experts. So, yeah. So let's begin. The first question we have is, based on your experiences, how long can we normally extend the oil service with the continued filtration practice? And how much is average cost saving with this practice?
I think we have the Fill for Life expert out here, Greg. I think he's the best guy who should answer this.
I can certainly start off with this. So I think there's a couple different things to unpack here. The first thing is filters will, an oil will fail for multiple reasons. An oil will fail due to contaminants, or an oil will fail due to stress on the fluid and the additives break down and degrade. Filters, and if we're just talking about normal mechanical filters, they're going to deal with the contaminants and not necessarily extend the life of additive components. So if the question is, how much longer will your oil last if you filter it? Well, actually, the additive system is not going to last longer. What filtration will enable you to do is basically maximize the life of that oil and be able to use it for as long as possible, and you consume all of the antioxidants and use all of the components as possible prior to failing. So I think that's the first thing. Oil filters won't extend the life of the oil. They will basically allow you to maximize the life of the oil. And the second thing, in terms of cost, I think you don't think of filtration in terms of how long you're going to extend the oil life and what the value of that is. Filtration is all about saving the equipment. And there have been multiple studies about this. SKF has done this. Noria has the life extension tables. Filtration and the value of filtration all comes in extending the life of your components. Extending the life of the oil is a nice, a nice added benefit. Running with clean oil is good, but really, the oil is really, really cheap compared to whatever components it's lubricating. And if you have the ability to extend the life of those components, now you're talking about really significant savings.
Okay, great. Anybody wants to add to this answer?
I think
yes.
Yeah, please go ahead, Rene. Yeah.
For me, it's very simple. We always have to act proactive in filtration. It means that when we can combine the removal of water and varnish and small particles, yeah, then we can enlarge the lifetime as long as we can. Important is which are the states of the antioxidants and how we control that. The only thing what we can do is when we combine the removal of these contaminants, we can only reduce the speed of the oxidation. And yeah, that's what I want to say additional about the cost. I have a fiscal rule. When I take, for example, a hydraulic oil of 800 liters, and I multiply that with the price of purchase. Yeah, then I know what the total cost is, because when I start to change an oil, I need to replace the filters. I need to clean the tank, and but in generally for hydraulic oil, I always multiply it with 3 with the oil volume and the dollars, and for turbine, for example, with 20. Yeah, so there are so then you have the total cost of an oil change and what you can spare when it enlarge 5 till 5 times, 7 times. Yeah, with filtration. Yep.
That's right. But at the same time, what about those fluids or oils which are extremely costly, like the synthetic fluids, for example, the electrohydraulic fluid, which is the phosphate ester fluid, which costs way high as compared to the mineral oils. And in those circumstances, the cost of the equipment components as well as the cost of the fluid itself, they are matching to each other. So in those circumstances where the volume of such critical fluids or highly costly or sophisticated fluids is high, I believe even filtration cost is not very high as compared to the oil cost or the lube cost.
Exactly. Yeah.
Yeah.
Okay, great. Let's move on to the next question. Is it true that TAN is the one that severely affects production by affecting servo? What are the methods to completely eliminate TAN or to control NAS?
For NAS, for NAS, I think filtration is the best method. Filtration using mechanical filters or electrostatic separation techniques. Of course, both have their own pros and cons. Like the mechanical filtration might be a little costly when it comes to the revenue or the consumables cost. But electrostatic separation would have its own challenges when it comes to their reliability towards preservance of the additive elements or additive levels in the fluid. So thereby one needs to take a call on which methodology to be used for doing the separation of particles when you want to achieve the NAS class. Also, one point needs to be remembered that if the volumes of oil are high, electrostatic systems won't work out there because they have a limitation in their capacity or flow rate, which probably would be not more than 20 liters per minute capacity. Or even if it's a very high system or a very advanced one, it might reach to a level of 40 liters per minute, but nothing more than that. And in electrostatic separation, the more you go ahead in terms of filtration capacity, probably you'd be losing out on the efficiency. But because it all depends upon the exposure of the oil, the exposure time to the electrodes and the plates inside the electrostatic system. And that's why mechanical filtration can be something which is having no boundaries in terms of the filtration capacity or the speed at which they can perform. So if you're using fiberglass absolute media, and nowadays there are media which have developed even up to 1000 beta or 2000 beta. So if you have a genuine filter arrangement, of course, and a correct selection of the filter elements in terms of the successive micron ratings, I believe for NAS filtration or NAS achievement, mechanical based filtration would be one of the most reliable solutions.
And also it was asked that how to eliminate tan totally. Elimination of tan is not the solution which will remain the same forever, because every time whenever oil is exposed to high temperature with high moisture, then again acid will form and tan value will go high. So elimination of tan cannot be done, but definitely we can stop the formation of acid. So for that, we can keep the oil moisture free. And it was asked in the question that how tan is affecting servo valves. These servo valves have very fine clearances. Even sometimes it is at the level of 1 micron. So high acid content first reduces the resistivity of the oil. So these servo valves are always in contact with the oil and their coil as well. So immediately coil will get oil of low resistance, and there is chance of short circuit of the coil. Then this acid forms minor pits on the servo valve spool, and further it hampers the easy movement of spool, and at last servo valve will fail. So high tan is the main reason for the failure of servo valves.
I'll just add on to that. I think one thing to take into consideration is the application. If we're dealing with phosphate ester fluids, when phosphate ester fluids hydrolyze in the presence of water, they can create high acids. And these are like phosphoric acids and some very, very strong corrosive acids that, as Yogesh just explained, they will destroy servo valves. When you're dealing with mineral-based lubricants used in hydraulic applications, high acid number is not usually, the failure mode is not through corrosion. High acid number is an indication of oxidation, and what is causing servo valves to fail in these applications is the formation of deposits and varnish, and that is really the #1 killer for servo valves. So in the case of mineral oils, addressing acid number may not be the highest priority thing. I think the highest priority thing is removing the oil degradation products that are leading to varnish and maintaining low membrane patch colorimetry or the MPC values. But lowering or keep maintaining low acid numbers in phosphate ester fluids is absolutely critical, and that can be achieved through adsorption medias. Fuller's earth can work, not ideal. Ion exchange resins are the optimum solution for phosphate ester fluids.
Yes, I'm agree with that. Yeah, so the deposits are the varnish are the most destructive things, because they block the small screens, the last protection screens of the servo valves, and they're only a centimeter, a cone high, and when they partly blocked, then the servo valve has already a problem.
I believe the biggest takeaway from what Greg and Renee have said, that if the tan values are increasing, which is actually not a very costly test to perform, so people can perform the tan value even at their own in-house laboratory with not very large investments in terms of laboratory capex. So if that value of tan can be maintained, a trend can be seen, and if there is a trend towards increasing tan, you can easily interpret that probably there would be some oxidation happening in that fluid, and that oxidation can ultimately lead to a lot of bigger problems in your fluid than just what TAN can cause in the mineral oil especially.
Yeah, that's true. Yeah.
Okay, great. So let's take the next question. How much water can be removed from the oil by filtration? And in how many hours should oil be changed?
The last in how many
Hours.
hours? Okay.
Yeah. Should oil be changed? Yeah.
So I believe filtration should not be the method. Filtration we normally use as a very common terminology for all the family of products in terms of oil reclamation or oil purification. But filtration is just a technology. It is not the nomenclature normally used for the entire family of these machineries or these technologies. So we should avoid the usage of filtration. We should use it only when we talk about mechanical filter-based separation. That is the area where you can use the term filtration of an oil. But when you talk about removal of water or moisture, the two terminologies which one should use is that is dehydration or dewatering or water separation. So there are multiple techniques to it. You have centrifugal technique, you have low vacuum dehydration, you have absorption, and you have coalescer. So there are 4 techniques which commonly are used in the industry based on the type of water contamination, based on the volume of the oil, based on the amount of water in totality in that oil volume. So if the volumes of oil are large and if the water is present in huge quantities, say 5% to 10%, which is very common in large sized centralized lubrication systems, probably the best solution would be a centrifuge or a coalescer. But when you have smaller amounts of water and moisture in the oil, which primarily are in the dissolved state or emulsified state, probably the centrifuge won't at all be very helpful for you if the water or moisture is in dissolved or emulsified state. So you would have to use a dehydration system or sometimes a coalescer system for that application. And the time taken to do that job will certainly depend on various factors, on the amount of water which is there in the oil, the type of water which is present in the oil, whether it is dissolved or is it emulsified or is it free. And also it depends upon the capacity of the machine which has been chosen for doing this dehydration activity. So multiple factors together would determine how much time it would take to dehydrate the oil sample or the oil volume.
Okay.
Okay. Anyone wants to add something to it?
Yes, in addition to it, filtration is closely to playing with the chemistry and physics properties of the system, and also oil is a system part. And when you understand that part, then you will have it's very easy to choose the right reclamation system or filter system. So, yeah.
Okay.
So it is not about, it's not only about mechanical hard material, but it's also about soft things like polar contaminants, and non-polar contaminants. And when you know what it is, then you can choose the right thing.
Okay. So let's take the next question. It is VG46 oil filtration possible?
Yes.
Yeah, of course. Why not?
Yes, of course.
That's an easy one.
46 oil is very simple to be filtered.
In fact, that's one of the most common lubricant oils which are available in the industry, because it's used for hydraulic systems, it's used for turbine systems, and many other commonly used lubrication systems, like the centralized lubrication for steel plants or paper plants or metal plants. So yes, ISO VG46 is one of the most commonly used lubricants, and yes, it can be filtered very easily and very efficiently. No doubt about it.
just add one small point that nobody here joining the call in India will realize or recognize. But when you are in the very northern parts of, say, Scandinavia or Canada, and you're trying to filter the very, very cold oil out, and it's minus 30 degrees,
yeah,
that is maybe one time where you're going to run into challenges with ISO 46. But
you're correct.
But I think the vast majority of cases, ISO 46 is an easy oil to
Recently, we were working on a project which was probably for Russia and Siberian region, and they had mentioned about ISO VG 46, but they never mentioned about the ambient temperature out there. And there, later on, when we worked up the inquiry and we gave up their solution, we could realize that there was a big mistake there, and the ambient temperatures were not considered.
Yeah, so the ISO 46, if you want to have a good filtration concept, you have to look at the viscosity index. Yeah, and when I have an oil completely of naphthenic, yeah, then you have more problems to filter that, or you have almost paraffinic. So take that also into account. But in generally, yeah, you can filter it. Yeah.
Okay, that's great. So the next question is divided into 3 parts. We have an oil filter machine with primary and secondary systems for oil filtration. How much time should we do primary and secondary filtration after using both filters? Can we reuse those filters, or do we have to change the filter as soon as oil filtration has been done for the next filtration process?
Right. So, Mr. Yogesh, you would like to take it up?
Yeah, sure. If we are going to use the machine for the same oil, then it is not required to change the filter for next filtration. Filter changing is totally DP based. Suppose one filter is consumed, so differential pressure across the filter will go high. After that only we have to go for filter changing. And how long we should do filtration cannot be defined in days or hours. It depends on when the required parameter has been achieved, then we can stop filtration.
So you mean it is not a time-based decision, but it's a KPI or goal-based decision?
Yes.
When you arrive at the parameter, when you achieve your targets of the filtration levels, you can stop the filtration at that moment. Yeah. And I believe the question guy, he was mentioning about 2 stages, like there are 2 stages. So which stage to be used till how long? So that would certainly depend upon the initial oil parameters. So you have a device called laser particle counter or a contamination monitor, which can give you the complete analysis of what micron size of particles are present in the oil. So if you can use that test methodology, it is NAS 1634 or ISO 4406, using a particle counter or a contamination monitor, probably you can understand your contaminated oil is having what levels of particles in what micron ranges. That would give you an understanding of what micron size of filters you have to use in your primary stage and in your secondary stage. So if the larger sized particles are very high in your oil, then probably you can use with a larger micron rating in the primary stage. However, if you feel that your contaminated oil does not have large size particles, it would be futile to go for bigger or higher micron ratings for the primer stage. So you could anyway start with a 10 micron or a 3 micron right in the primary stage as well. So everything depends on what kind of planning you have done towards filtration. So before starting off any filtration activity, it is important to know what is the condition of the before filtration oil. And that's why a detailed analysis needs to be performed. If you are a service provider or you are a maintenance guy, you need to first take a call on what is the current value and what is the ultimate value at which you want to arrive at.
Rene, would you like to add something to it?
Yes, if I understand right, the primary and secondary filter is placed in series, isn't it?
Yeah, that's true.
Yeah, so my experience is when you had used two beta filters, beta ratio filters of 60 micron, the first one, 60 micron beta, and afterwards 3 micron, then the speed is of removing the small particles is huge. So when the machine is also in operation, is warm, it's more than double is the speed of reaching the NIS values. So I think it's a good concept, but you have to use two beta ratio filters, but the first one roughly tops it of the other one. So I think it's a good concept.
Right. Great.
Yeah. And when you do free particle beta ratio filters, it goes not faster, really. Okay, that's my what I have done. Yeah.
Right. Right. Certainly, based on your field experience, I believe that ratio or that proportion would be applicable for most of the applications of oils, I believe.
Yeah. Mm-hmm.
Because we have also observed something. Various oils have different distribution patterns. So if you talk about a turbine fluid, probably the pattern of various sizes of micron would be different as compared to the lubricant which comes out from a gear oil of a coal mill or some other heavy application. So the pattern or the distribution configuration of the particles in oil is very important. And it would depend upon the application, the machinery, the lubrication type, a lot of those parameters.
Yeah, that's an interesting point what you just say. Okay, I believe that. Yeah.
Probably if you could take up some research project to understand various patterns and
Yeah.
draw a mathematical model around it, I think that would be very helpful for such decision makings.
Yeah, that's a point. Okay.
Okay. So there is a question for our audience here. Which contaminant troubles your machine the most? Is it solid contaminants, moisture, acid? Please comment on the chat box.
Do we have to answer that?
No, it's for the audience.
So I think it really does come down to the application. And generally, most people consider the number one biggest contaminant in oil is dirt. Number two is water. Number three is air. And I would say varnish, depending on the application, is very, very high up on that list as well. But those are the three most damaging contaminants that oil face. A lot of people don't even think of air, but that actually can be a really significant contaminant in lubricants as well.
Yeah. And when we look at the contaminants, the first one, what Greg was mentioning, we can divide it into internal and external contaminants. And when we look at the internal contaminants, it's the biggest one, because it has everything to do with the precision maintenance. How good is the alignment, the balancing, the using an M-torque, or what else the first fill, and there's a lot of things what is going wrong. Yeah, so also the breather, an inadequate breather is something what belongs to the internal contaminants. Yeah. Okay.
Okay. Mr. Anshuman, you would like to add something to it?
No, perfectly well said, because it all depends upon the application, and that's why we have come across paper machinery, where water is one of the major issues. Yeah. Then we have come across control fluids of thermal power plants, where both moisture and solids, they play a role together, and the TAN value goes high to exorbitant levels. So certainly it depends upon the machinery, the upkeep of that machinery, the surrounding environment, how the applications are rolling. So it's very difficult, and that's why it is important to understand what the audience poll actually answers. That would probably give an indication of the audience belongs to what kind of sector.
Yeah. So related to that, let's take the next question. Filtering the oil may remove solid contaminants. In the refinery case of hydrocarbons dilution, what filtration can be used? What is your opinion on using OEM recommended oil?
I think this is about the cross contamination which happens in the reciprocating compressors.
Yeah.
the gas, the process gas getting contaminated into the compressor oil?
So I think the first part of that, in many cases, there are places to capture gases, process gases that migrate into compressor oils, and OEMs will often design a capture system for these gases. If the gases, if you're not able to extract them through a normal evaporation process that's integrated into the system design, there are coalescers that can be used. There's liquid coalescers and air liquid separators. In some cases, those can be used to separate some of the process gases out as well.
Right. So what, Greg, if all these preventives, they don't work and the process gets mixed up? For example, we have come across ammonia getting mixed up in the compressor oil chamber very often.
Yes.
And most of our clients in the refinery sector, they are always worried about ammonia getting into the chamber. So
yes.
Do you think there is some separation technique for removal of ammonia? Do you think LVDH, low vacuum dehydrators, can do the task?
You would need not a normal vacuum dehydration system. You'd need a distillation system. So you need a much higher temperature and vacuum. But in many cases, you're exactly right. Especially ammonia, it can really beat the oil up very quickly. And by introducing ammonia, you are now introducing multiple new degradation pathways for the oil to fail. So it is this is a very detailed good question, because actually there's once you start influencing the degradation pathways with various different gases, now things become very complex, and that's typically why we see, in compressor applications, you often see they're often using a turbine oil. The bearing temperatures are similar, the RPMs may be similar to turbine oils, but they may fail much more rapidly than in a turbine system because of the influence of gases. It can really accelerate fluid degradation.
Right. So do you think the OEM recommended fluids for the compressors, they have those kind of additives which can ward off these ammonia contaminations if in low levels?
So the OEM recommended oils, I think I prefer when the OEM has either a recommendation or specs that the oils have to meet, or if the OEM actually takes the oil, tests it, and then approves it for use in their application. Whenever an OEM is selling their oil for this application, the OEMs, if they're making compressors, they're not oil experts. They're buying the oil from someone else, and now this becomes a profit center for them. And I think their recommendation using their oil is also financially driven and not just technically driven. So I think it's always preferable to have just a specification that you are now responsible to make sure you buy your oil that meets this established specification, rather than just buying the OEM oil.
So don't you think there are any additives or aftermarket additives or solvents kind of products which have been developed, or they are under progress of development for such contaminations, like hydrocarbon gas contamination?
Not that I am aware of, no.
So probably another point of research for you guys.
Yes, there's no shortage of those. You're exactly right.
Great. So it's better to prevent the addition of hydrocarbon into the oil chamber of compressors rather than trying to separate it out with various methods and ways, because probably, as Greg explained, it would open different avenues for oil degradation if this hydrocarbon gets entered into the oil chamber.
Yeah. May I say something about that?
Yes, please.
Yeah, I look from another way. In a compressor, you look at first at what kind of oil it is. What is the basic? Is it naphthenics? Yeah, or what is the percentage of naphthenics? Because how higher the percentage, how higher the solvency. And the more water, the more gases will dissolve into the base oil. That's one. Second, when it go to the high pressure chambers, then the bubbles, the air bubbles, the gas bubbles, they will compress together, and it can lead to adiabatic compression, for example. Yeah, and this leads to enormous temperature increases, which can damage the oil around the bubble, and that causes the varnish. So when we want to treat the compressor oil, there are three enemies. Yeah, about the gas. What is the quantity? Second, what is the water quantity? And what is the base? Can be separated from an naphthenic oil or a PG or what? Yeah, so it's a fight, yeah, against three enemies. Yeah, and not and that's why I want to say additional. Okay.
Yeah, that's a very good point. There are absolutely base oils that are will mitigate or will not dissolve as much gas. So you're absolutely right. PEGs are an example of the one chemistry that's often used.
Yeah. Okay.
Very good point.
Okay, let's move on. The next question is, what can be the best technique to remove moisture content from the oil?
I think we explained it in short. Yeah, the kind of techniques which we have, and depends upon the type of moisture and the quantity of moisture or water.
Okay, anything on the best technique?
If technically,
application. That's a very general question.
Yeah, yeah. Technically, it can be said that low vacuum dehydrators can remove all three forms of moisture. So you can say that they are the most versatile equipment, but not the best, because there would be situations where the free water contamination would be too high. And if you adopt a low vacuum dehydrator in those circumstances, probably you would lose a lot of time to remove free water, which could have been removed by settling techniques or gravity separation techniques or centrifugal techniques.
Very good point. And also, if you have a 50-liter pump with oil in it, you know, filtering the free water out of the oil is absolutely possible with the absorbent filters. And in that, it's totally inefficient for a large system. But for a very small system, you can use an absorbent filter. You're not going to hook a large vacuum dehydration system up to a 50-liter system. Yeah. So again, it really does come down to the application. EHC is also its own kind of special little application where you would probably look at a different form of deploying dry gas in the headspace to mitigate water contamination. So the best is very subjective based on the application.
Yeah, probably the audience wants to understand, just give one solution, we will buy that system and forget it. So probably that can't happen, and you need to go case to case basis. And there's no one single solution that can handle all the situations and scenarios. That's what machineries is all about.
Yeah.
Mm-hmm. Well stated.
It's not a Harry Potter play that we are going to have.
Yeah.
Agree.
Yeah. So the next question is, what is the minimum size of the filter element in the filtration stage?
Probably the micron rating is what they are asking. So depends upon the application, but if you talk about the finest filtration in terms of mechanical filters, it's around 1 micron, which is very commonly used. You can also go down to 0.5 micron levels in mechanical filtration, but that's a range where you are risking the separation of additives as well. If you go further down in absolute filtration does not just work at the rated filtration micron, but it can work also at a lower filtration micron than what has been rated for that filter. So what I mean to say is, if you buy a filter of 1 micron, which is rated absolute filter for 1 micron, you are also removing particles smaller than 1 micron, because that's the way how these depth type filter technologies are made. And thereby, if you keep going down, there will be a risk that you are removing the additives also from the oil. So it's always safer and sound to go with a 1 micron or a 3 micron filter, which probably would be more than enough for your job.
About the 1 micron, are you talking about inline or offline?
I was talking about offline, certainly not inline, because
Okay.
if it's inline, then probably it will have a very high back pressure and the system won't function at all in that circumstance.
Yeah,
For inline, which is a system filter, I think 10 micron would be already too, adventurous.
Okay.
Yeah.
And the size is also depending of the media, the filter media. If you use cellulose or glass fiber or microglass or a mixture of full earth, what else? Yeah, it all depends on the resistance of the media. Yeah, will it be break because of the viscosity? Yeah, the viscosity can very high, and to high counter pressure, it will crack all the media, and that's also important. So to decrease the pressure against the filter, you have to increase in size or in surfaces. Yeah,
that's right.
And just one more small point I'll make on that. The point of the filter system is not to see how low you can filter and how clean you can get the oil. The goal is to remove clearance size particles. So it really depends on the application. But if you're in a large gearbox and the clearance size particles are 20 microns, you probably use a 15 micron filter to remove the clearance size particles. Those are the things that are going to cause the most damage. But very good comments already. Just a quick add on to that.
Exactly. So we should never go too bullish in terms of selection of the finest micron range. So it would always depend upon the application. So for example, as Greg said, if it's a gear oil application and we plan for a 1 micron filtration, probably it is not the right way how you are doing the filtration.
Yeah, and you know why? Because the acidities or the surfaces, there must be a certain roughness, otherwise the additives will not cling to it. Okay. When you are to filter too small for a gearbox, yeah, then the oil of the additives will not. I'm still there, but the additives will not cling on the surfaces. So too smooth is also too bad. Yeah. I had some experience with that. I never forget. And on a truck, I install a bypass filter of almost 3 micron on a new truck, and within 500 kilometers, the motor was totally broke because the piston sizes, the surface was too smooth. Yeah, there was no oil. There was no oil between it. So I learned my lesson about that.
Okay, great. Thanks for sharing.
Yeah.
The next question is, can the filtration of oil be carried out after the oil gives desired life, say 4,000 or 5,000 hours, and we get extra life from the same oil?
I think Greg had an answer related to this, the first question. So he'll be the best guy to answer this in continuation.
Yeah, I think it really comes down to, it is very much related to the first question. It really comes down to the additive components. After 4,000 to 5,000 hours, if you still have a healthy antioxidant system, you still have healthy additives, absolutely, filtering will be fantastic to help extend the life. But if your additives are gone, your antioxidants are depleted, you can filter it all you want, and it's not going to extend the life of the oil.
Yeah.
But what if there is no additive in the initial oil, as good as a turbine oil?
Oh, so there are some applications that have no additives, but esters would be a good example of that, where there are no antioxidants or additive components, 100% phosphate ester fluid. But in a case like that, certainly filtration is important, but you're more interested in removing acids and acid scavenging rather than just filtration.
Yeah.
But most other industrial applications, heat transfer fluids, you may have some heat transfer fluids that have no antioxidant or no additive components whatsoever. But most other applications, you're going to have some type of protection. Base oil itself, you just throw a little bit of heat on base oil and it degrades really quickly. So you do need to protect that with antioxidants.
Yeah.
Okay. So the next question is, what is the payback time of the filtration system in the compressor system? How is lube oil filtration more economical than replacement?
Again, depends.
So I
upon
think
the
we discussed this as well. Again, if you're looking at the payback time for a filter system, don't think about the replacement cost of the oil. I mean, you can in some applications, and as Anshuman described, phosphoester fluids, there are some chemistries that are very expensive, but filtering the oil will extend the life of your components, and that's where the payback is. You can literally double the life of some of your components, and the cost of a bearing in a large frame gas turbine is significantly more than a charge of oil. So you really filtering is not, you don't compare just oil change costs, you compare the life of your system.
I think the question was towards a compressor system. So yes, if the compressor system has got costly components, and if the criticality is high of the compressor system, probably you don't have a standby for this compressor. If it's a refinery or a fertilizer application where you have to compress certain process gas, then probably you can't lose a single minute of breakdown for that compressor system. And that's the region where the ROI will not be in terms of savings of your compressor oil or fluid, but the ROI will be in terms of saving of those 1 minute or 2 minute breakdowns, or maybe more than that. So the ROI calculation needs to check out how many times your breakdown happened on that rotary equipment during the last few years, what has been the trend, and what have been those root cause analysis around it. How many of those breakdowns could be traced towards poor lubrication or poor contamination levels. So based on that, you can calculate the ROI, of course. But not in all cases you would get an ROI in terms of savings towards the lubricant or savings towards that oil. So it's always better to take a 360-degree view towards saving towards breakdowns, saving towards spare part replacements, saving towards consumable replacements. Many times I've seen people getting habituated towards change of consumables like the inner lining of the bearings or the seals of rubber or other material. So people become habituated. They say that, okay, if it's a lubrication system, we ought to change these consumables at certain overhauls or turnarounds. But that's not the case. If you can maintain your lubricant to a purity level, probably these consumable changes won't happen at all. And those themselves would give you a very strong ROI basis.
I would like to add that we calculate ROI in terms of revenue only. If we are going to change the oil, we are leaving huge carbon footprint behind. The carbon which was generated during the oil manufacturing and which will be generated during disposal. So oil change is not only in the terms of revenue, but in terms of environment also we have to think.
Exactly. Yeah.
That's an excellent point of view.
That's a good point. Yeah.
Certainly the carbon footprint which is left because of the manufacturing process of any oil lubricant, that's immensely high, and you can always do that bit of your contribution by not changing the oil, rather using it for a longer time or having a life extension.
Yeah, and about the safety and health of the personnel. Yes. Yeah, if we damage, repair, it has a risk that somebody get injured. So, and then you can, and especially in this kind of work, yeah, it can happen very quickly, especially with gases and so on. Yeah, so okay.
Okay, great. So the next question is, how can we avoid over lubrication? how do you decide how much is required for which bearing? Rene, would you like to take this?
Yeah, I read a question and I thought it was about oil. So I was also thinking in grease. Yeah, bearings of grease, bearings filled with oil. Yeah, you have to avoid over greasing. And for example, in grease, yeah, then you can mention something also in a bearing with oil. When you replace a bearing, yeah, you have an initial fill, but almost 20-30% of the volume inside, and depends on the way how it greases. But can you imagine 3-4 years later it is full? Yeah, we are over greasing. It's also over greasing. With oil, it's the same. When we are looking to the for a paper mill industry, and we are in the wet section, drying sections, there are a lot of possibilities for over lubricating. And why? Because the machine speed is going faster, and the return line of the machines, of the bearings, are not modified or are too contaminated and on the broader side. And what happens? Overheating of the bearings. Yeah, so bearings are damaged and so on. The oil degrades very fast. So over greasing, over lubricating, we have to avoid that. Yeah, so build up for grease a vent valve. Yeah, make a hole inside the housing. Is nothing can happen with that when there's a hole, no entrance of water, and in an oil system, enlarge, for example, the drains. Yeah. Okay, that's.
Yeah. Mr. Yogesh, would you like to add something to it?
Yeah, to avoid over lubrication, we must know that how much quantity is required. Suppose we take an example, bearing number 6310. It takes only 4 gram of grease to run for a year. What we do, we normally put 50 gram of grease every week. So why we do so? Because of dust and contaminants, we always fill the fresh grease to remove the older one. So if we maintain the equipment clean and surrounding clean, then certainly we can avoid over lubrication.
Okay.
Okay. So the next question is sent to us by Bobin Anto. What is the expected life of mineral oil in the turbine lubrication system and control system? Can we reduce the oil top-up per year to less than 0.5% of tank capacity? And is it possible to make the same characteristic?
A lot of questions.
I can start off with that, and I think you need to break this up into control oil, which is a totally different species than mineral oil for your bearings, your turbine. In a turbine system, so just the average life, and again, there's all sorts of things you could do to extend the life, but the more thermally stressful the environment is, the shorter the life of the oil. In general, hydroelectric turbines are a wonderful place for turbine oil. If you're a turbine oil molecule, you want to live in a hydroelectric turbine because you will have a very, very long life. You can live definitely for 30 years plus in a hydroelectric turbine. Steam turbines, you're typically looking at 12 to 15 years. Gas turbines, the average age is maybe 8 years. But again, all of this comes down to, and no turbine oil should be changed based on a time. It should all be changed based on condition. So you can do lots of things to extend the life of the oil if you properly maintain and take care of the oil. But change your oil, not based on time, do that based on condition.
Yeah.
And I'll just, one quick comment on phosphate ester fluids that are on the control fluid side. Again, these are additive free, 100% phosphate ester chemistry, and these can literally last for the life of your equipment. When it degrades, you have the phosphate ester molecule, it'll degrade and produce a chunk of acid. You can also produce some other lighter alcohols that can go on and create some varnishes. But if you can remove the degradation products, you're basically bringing this back to 100% phosphate ester molecule. So the first company that ever used ion exchange and phosphate ester fluids was a power plant in Germany, and they were experimenting with different resins. They found a resin that performed well for removing acids, and they published a paper in the early 80s. I saw this power plant again several years ago present another paper basically showing the effects of how their filtration has worked. And they're using the same oil since the 80s, since the early 80s, and they're still using the same oil today. If phosphate ester fluids are really hard to maintain, they're very finicky, but if you do a good job maintaining them, you're removing the degradation products, you're minimizing the amount of moisture that's getting into the fluid, they theoretically can be a fill for life oil.
Yeah, please continue.
Yeah, that's true. I remember that story. Yeah, so what you have to know from phosphate esters is about you look at these specific gravity. Yeah, it's larger than water. Yeah, so what happens? The water don't drop, but will increase to the surface. We go to the surface, and when you have the opportunity to take away that water there, then the phosphate ester will live a long time. Almost 56% of a phosphate ester oil is phosphor. Yeah, because of fire, against fire of resistance lubricant, and I treat a lot of these kind of systems, and yeah, water is an enemy. Is water not quite treated, then varnish will come, and then you need a varnish removal system. That's yeah. But the first step is always put an adequate air breather on it. Yeah, so moisture from the hot room where these machines are. Yeah, the water cannot enter the reservoir. Okay.
Yeah, so it was also asked that can we reduce the oil top up, that is 0.5% per year. In case of steam turbines,
Yeah.
oil fumes are generated, and we have to top up the oil to replenish this fume generated losses.
Mm-hmm.
So this cannot be avoided because oil acts as bearing cooling media there. So fume will certainly generate. In a few plants, they started the condensation of fumes and they are collecting it back. But those fumes are already oxidized oil. So it is not advisable to reuse them or use for the top up.
Yeah, but most of these reservoirs are supplied with a blower, vacuum blower, yeah, to suck the fumes away. And when you treated phosphate esters, it's a concept. It's not about filtration. You have to understand the chemistry of the oil, the way the maintenance is organized, yeah, and what are the other apparatus. So filter mist. Yeah, the iodation unit, an air breather is a concept. Yeah, it is not that filtration. No, there's more. Yeah, also an instruction in, for example, in ERP system. Yeah, when they have to take an oil sample, where also important things. The cooling temperature, control the cooling temperature. It must be low as possible. Yeah, all kinds of things. It's not filter. It's additional to other issues. Yeah.
Okay. Yeah, so I was having a conversation with Renee and Greg the other day and got to know that they are writing a book, which is quite exciting. So I would like to know more about the book's highlights, and I'm sure the audience too wants to know. Can you please shed some light on that? We can start with Greg.
Well, so I'm co-authoring a book on varnish, which will be out by the end of this year. I've spent most of my career studying varnish and turbo machinery, so and have a lot of papers on this. So it's more just coalescing all of the information and studies that we've done over the years. But I think it will be addressing basically everything that why oils break down, how to go about selecting oils, and in fact, there's a lot of new studies that are in there as well, and then all sorts of methodologies that you can employ to extend the life of the oil and ultimately operate with varnish-free oil. So we're excited. My co-author is Sanya Mathura. So she's written several other books, and so I'm honored to be co-authoring a book with her on this.
Okay.
Great. Rene, what about you?
You are surprising me. My job is, that's my mission. And you can see on my website, my mission is to leave something behind. When I'm not here anymore, and it must be very short, precisely, and I think that in 25 pages, then that everybody in the lubrication world, maintenance world, all analyzed world have the missing links between all kinds of disciplines and also in organization. And that's what I want to finish, and and give it for free worldwide. That's my personal mission. So, yeah.
Okay.
Looking forward for the book launch.
Yeah. Okay.
We'll go on a book tour together, Rene.
Okay. Yeah, I hope it will succeed, but I think with it will. Yeah.
Okay, great. So let's take the next question. It is how to maintain oil NAS value. Which machine is best for it?
Oh,
The repeat question, I think. So for NAS, we have I think answered regarding filtration.
Yeah. Okay.
may I say something about that?
Yeah, of course.
Yes, please.
say.
Yes, maintain NAS value is the same as maintain the airspace of the headspace in a reservoir and all space. So this plus and this plus. So to maintain the headspace, it must be keep dry and clean. Yeah, and cool. The same is also for the all space. And most people think, oh, NAS, I need a figure, but this figure contains 3 items. Yeah, cool, clean, and dry. So, and the fourth, this for myself, is the oil level. When you don't keep the oil levels stable, then you will have problems with the NAS value. So, the best machine of the best system concept is to look for systems which are combined in removing polar contaminants, water, oxygen, varnish, and that's what, and there are such machines are present in the market. Okay.
My answer is very simple. Minimac, they'll sell you the best system.
Yeah, I was so surprised at the introduction. Unbelievable, very good. Yeah. Okay.
Yeah. So I have another question for our audience. So what do you think oil reclamation is necessary for which purpose? To save money, equipment reliability, sustainable development, what? So meanwhile, our experts can shed some light on oil reclamation.
Great question. So ultimately, you don't want to do anything at your plant that could introduce an element of risk. So the number one thing is oil reclamation can save the world, can be fantastic, but if it's introducing extra risk to your operation, it doesn't make sense. So the number one thing is reliability of your equipment and maintaining good operational risk. Secondly, if you do have a good oil reclamation program, you should expect significant savings on a significant reduction in your oil costs, and it is possible to actually improve your reliability with a good oil reclamation program as well. And then finally, reclaiming oil will have a very, very significant impact on your CO2 equivalent. So if you look at a life cycle analysis where you look at multiple different metrics on the impact that materials have in the world, global warming potential is one. It's measured by CO2 equivalent. And it is approximately 1 kilogram of CO2 per liter to be able to extract an oil out, manufacture it, refine it. However, once you actually package this, send this to the site, and then you have all sorts of other processes that are involved in this. And then at the end of its life, you're taking all of these hydrocarbons and in many cases burning them. Now your CO2 impact is actually several times higher than that. So actually, that's something we've been doing a paper on this summer specifically on that. So, but the bottom line is a good oil reclamation program, you should have increased reliability, potentially decrease risk to your operation, increase savings and lower cost for your oil. And then ultimately you will be lowering your carbon footprint as well.
Yeah, and what nowadays is actual, that's because of the war in Ukraine, is that the delivery of all the specific lubricants like the PAOs, the SE, they are 3-4 months already here in Europe. Yeah, so reclamation of these oils is worth to do it. I do it with one customer only because it's 3-4 months delivery time for critical machines. So that's an argument to do it. Yeah.
Right. So do we have a number on what's the total volume of lube which is being produced on a yearly basis? And what's the total amount of lube that is, getting disposed of after the life is over, so that we can understand what is the global impact of lubes?
I don't have that off the top of my head, but I do have that information. So anyone that is interested, I can certainly follow up with that. But yeah, there are Klein produces a report every year that talks about the total demand of lubricants. And typically each country actually will have a report on what percentage is improperly disposed of, what percentage is re-refined, and then what percentage is combusted or incinerated. But so that information is available. I just don't have that off the top of my head.
Like one figure which I am having regarding India is we use 16% of the total lube of the world, which is around 1/6 of the total lube which is being produced and being sold off in the market. So certainly that's a big number, 16% in one single country.
Amazing. Well, you have about 1/6 of the population of the world, I think, as well. so maybe there's some correlation there.
That's proportionate.
Okay. So we have received a question from Mr. Pradeep Prabhu. Do we have any web-enabled or IoT-enabled filtration machines so as to know the real-time situation as the equipments are installed in different remote locations?
Yeah,
Yogesh,
so
you would like to add it?
Okay, Yogesh?
Yeah, sure. Certainly we have IoT-based filtration machines, and even they are automated to that level that whenever contamination level is high, machine will start automatically. It will clean the oil, and once NAS or whatever the criteria we have set, once oil reaches that level, machine will stop automatically, and we can access the data from anywhere in the world. Data is always available on cloud.
Yeah, Greg, I think you were adding to it.
So I think that you're exactly right. That's a good explanation. Oil contamination sensors have been around for years, and they're reliable, and they make a lot of sense. there's incredible power, though, if you're able to actually connect that and put that data in the cloud and then start to correlate that with other production data in your operation. So, but Yogesh, I think you described this very well.
I think the wind turbines would be the best application where IoT can be enabled immediately with regards to purification and oil analysis, because they are at remote locations. You don't climb onto a wind turbine gearbox every now and then to do the sampling or do the filtration manually. So probably that would be the finest example where you can implement the IoT immediately.
I think that's a very good point. I often, I often wonder why we've had all sorts of fantastic sensors available for many, many, many years, but actually the number of people that are using sensors, it's extremely small. And so I think the reason why is, number one, as you say, it's pretty, if you have an offshore wind turbine, you're only getting out there once a year, and extracting an oil sample is really challenging. Whereas if you're at the plant, it's very easy to take a sample and send it off to the lab. This will change with IoT, though, because once you actually are able to correlate your data to actually production data, then your oil data actually can help you improve the productivity of your plant. It's an incredible untapped source of data that, so I think I am very bullish about sensors and the opportunity for sensors, but sensors will not take off until there's a direct correlation to actually productivity. And so customers, instead of just having a sensor instead of pulling an oil sample, it's hard to justify that. But if you're able to improve the productivity of your plant, that's a really easy justification.
Wow, I can just imagine the situation where you have a breakdown and then you start doing the trend monitoring, and then you understand that yes, that breakdown has happened because the oil contamination was high. And going ahead, extrapolating the situation, as soon as your oil starts having some contamination, the system itself starts giving you an alarm that probably your system would break down in certain days. And when your operator does not take a heed of it, the system actually breaks down. Something like the cognitive cops of Minority Report.
Yeah. About the gearbox in the windmills.
Yeah.
May I say something? Yeah. Okay. I have a software package. Yeah. Created by my own with my. I have a partner in that, and we have here a firm in the Netherlands. It's called economical, and we have 34,000 wind turbines in our software. So we and it's also investment of economical self in the IoT. Yeah, all kinds of sensors. It doesn't matter. We can follow everything, but no oil sensor, no 10 sensor, nothing like that. And you know why? Because of the air in the gearboxes. Yeah, there are no reliable oil sensors which can give the right values. And it's not a matter of price, but it's a matter of how how can we overcome that lack of the sensors, of this oil conditioning. And if somebody has something like that, let us know. Maybe I can do something. So, yeah.
Yeah.
Okay.
Okay. So the
We may be having a connection trouble here, it looks like.
Yeah. I think we can pick up the question ourselves. There's a question for, I think it was marked for Greg.
Let's see, I'm looking at the.
Yeah, it's when we are doing ester fluid ruler, we are unable to get the peaks. Any reason behind this?
Okay.
And the MPC have no issues.
Okay, very good question. That We manufacture this instrument called the ruler, so I do have some good information on that. The ruler is measuring antioxidants, and so in phosphate ester fluids there are in fact no antioxidants. There's no additive components whatsoever. So in a new phosphate ester fluid, you'll see pretty much a flat curve. You'll see no humps indicating antioxidants. However, phosphate ester fluids are pretty unique in that when they degrade, they also produce, I said earlier, they produce a chunk of acid. They also produce a chunk of alcohol, and it's specifically known as a phenolic alcohol. Well, that actually can be measured with a ruler. So the ruler is a really effective device at measuring oil degradation molecules from phosphate ester fluids, but instead of starting with peaks of antioxidants and watching those peaks deplete and measuring the health of the antioxidants, you're actually watching a peak grow as a fluid ages, and it's another methodology at measuring degradation products in phosphate ester fluids.
Oh, that's great.
Yeah.
You have to add to it.
It has to do with it's not a hydrolyze reaction, but a de-ester reaction. Yeah, so it forms alcohol and carbonylic acid. Yeah, that's, yeah, okay.
So there's another question with regards to varnish, Greg, and it talks about, couldn't you indicate whether a soluble varnish removal system can help restore the demulsibility of a steam turbine lubricant?
Okay. So I have there have been some discussions about that in the industry. So we did actually, you know what? I saw that question in the chat, and I pulled up an image from a study that we did. So if it's okay with you, I'm just going to share my screen for a moment.
Yeah, of course. Please go ahead.
Let's see here. Okay, so.
Wow, you have ready.
Okay, so let me, the premise is that oil degradation products are polar, and if you have polar constituents that get into the oil, you will disrupt the oil's ability to shed water. So the first part of that is correct. Any polar constituents that get into the oil will ruin that oil's natural ability to separate from water. So the premise is that if you can remove these, and some degradation products are polar, some are not, but if you can remove these degradation products, maybe you can improve the demulsibility. So that's the premise of this question. We did some research and basically we looked at 350 samples, and here I'm plotting on the x-axis the amount of emulsion. So in the demulsibility test, you're measuring three parameters: the amount of free water, the amount of oil, and then right in between the emulsion layer. So this is basically the emulsion layer and on the x-axis. On the y-axis, you have MPCs. So you see a lot of oils here that have good demulsibility, no emulsions whatsoever, but also have MPCs ranging as high as 60, a lot of population here. Then you see all sorts of other, high MPCs and also very, very low MPCs with poor demulsibility. Basically, if you look at the correlation of this, the correlation between MPC and demulsibility is 0.06. If you have a 1, that's perfect correlation, or if you have a -1, that's perfect correlation. 0.06 means there's no correlation. So in fact, there is no correlation between oil degradation products and demulsibility. So putting a system on that can remove oil degradation products, there's all sorts of benefits with it, but you're not going to restore demulsibility. And we've seen this dozens of times in the field as well, but I think this study kind of helped determine that for us as well, that there's just not a correlation between the two.
That's great. So your answer supported with experimental evidence as well. Yeah, Jumpai, if you are back with the network, you can carry on with the questions.
Yes, sure. So I'm not sure which questions are already taken.
They are all answered, whichever they have been marked as answered. So you can go ahead with the new one.
Oh, okay. Okay. The next question is asked by Karuna Nithi. For water contaminated hydraulic oil, laser particle count is the correct method, or do you recommend any other type of filtration technique?
So yeah, laser particle counters, if you are using for measurement of NAS class in a hazy oil solution, probably you don't get the correct results, because for the success of particle counters, which are based on LED light obstruction or laser obstruction, the transparency of the oil is very important. The haziness might lead to incorrect results. So when it's an emulsified solution, which you are trying to test with these instruments, probably you won't get the right results. So it's very important first to get it demulsified, and then you use these methods for doing the testing. As an alternate, I can recommend you can go with the conventional patch testing method, which is done on a membrane of patch size 0.45 microns or 0.8 microns. And then if you have to do a detailed analysis of it, you could probably go with a microscopic analysis, because these patches would not be catching up the moisture, but they would be catching up only with the solid particles. So if you have heavy contamination of moisture in the oil and you want to perform the NAS class testing, probably you would have to go with patch testing and a microscopic analysis.
Yeah, and the poor blockage method.
Yes, which is certainly based on a similar technique.
Yeah, that's okay.
Okay. So the next question is, can we replace the oil or lubricant after condition monitoring?
Yes, of course. If the conditions are not well, then probably you would have to either go for reclamation or a replacement if the reclamation is not possible.
Okay, Mr. Yogesh, would you like to add something to it?
Whenever we say that oil condition is not good and we have to do the replacement, about what condition we are talking. Oil condition is not good. It may be due to contamination also, moisture ingress also, high acid number also. So first option will be always reclamation. If oil is degraded chemically, then certainly replacement is the only option.
Okay. Okay, let's take the last question for the evening. What should be the ideal supply oil temperature for a forced oil lubrication system?
The oil temperature? Okay.
What should be the ideal supply oil temperature for a forced oil lubrication system?
Yeah, what I recommend is that you have to avoid a temperature shock, of almost 8 degrees, because when it's more, then you go to an ISO, to a degrees in ISO class, ISO VG class. Yeah, for example, when your oil is 150 and you go with 10, 12 degrees lower, it's cooling, because lubrication is not only reduce friction, but also cooling, take heat away, then it's possible that you can go to a 220, and maybe 300. So that's not what a bearing like to work with it. So you have to always avoid it. Yeah. So you take the, for example, 60 degrees also oil temperature, what is inside the bearing, and then decrease it with 8 at least, at most 8 degrees Celsius.
Okay, anybody wants to add to it?
Renee has more expertise on this than I do, so I'll leave this one to the expert.
Okay.
Okay, great. So before signing off for today, I would like to announce our next webinar, which is how to reduce lubricant consumption in steel, mineral, and mining industry. The date for this webinar is 22nd August. You can find the registration link in the chat box. You could register for it right away. Also, let us know how did you like today's webinar via the feedback forms after this webinar. And just an update about the LubeBus quiz. We have a new set of questions. In the quiz, please visit our website and attempt it and claim your free certificate. Lastly, I would like to thank our experts for their time and answering all the questions. Thanks, Rene, for managing and joining us from the ship.
Yeah.
So,
Why don't you show us around, Rene?
Yeah.
Thank you.
Yeah, so if any questions are still unanswered, we'll answer them in the FAQ document and share it with you all. Thank you for thank you for joining, and don't forget to take the survey after this webinar because your feedback matters. See you in the next webinar. Thank you.
Yeah, and a compliment from my side for what you have done.
Yes.
Okay. Thank you.
Thank you so much, webinar team.
Thank you.